Yeah. Here's a picture where I live right now. Uh, I'm out in Arkansas. So who am I? I'm Vinnie Moscaritolo. I'm a retired engineer, right? Finally walked away from Silicon Valley. I was doing search and rescue for a while and finally decided, we're done with that. Um, I'm kind of a original homebrew computer guy back in the 70s before there was an Altair. I was building homebrew stuff out of 8008s and crazy stuff like that. So I've been, back and forth between hardware and software over the decades. Um, Man, it's crazy when I think about it. It's like that's like 50 years. It's half a century. Um, Moved out of Oregon and I now have this farm out here in Arkansas. We grow vegetables that we sell at the farmers market. There's cattle out here and chickens, but the cattle is my belongs to my neighbors. But mostly what I do these days is I make cool things, and I welcome you to go take a look at the website. Everything I write about, I put on Substack. Everything I talk about, I build, I put on Substack. All the stuff's open source. This is all about sharing. So we started with this whole. What I want to talk about is how I do this irrigation automation or farm automation in general. And this thing started back in Oregon, pre-COVID, maybe even around more of that. We were trying to be a little more self-sufficient. So, we said, I can't totally get off grid. I was living in a place where there wasn't a lot of sunlight just because of where the hills were. I was on the wrong side of a hill. And so we tried our best to do some solar power, do it off grid. And we built a garden bed. And what's really interesting in that picture there of the garden beds, um, we made it so that the little covers had actuators that could open and close. And so in certain months, we would keep them warm, or in the evening, and then nighttime they would close. Um, and I used Open Sprinkler as a platform. What that little box on the side is just basically was my power backup because the solar would do what it could, and then when that sun went away, I still needed to have the computer run. And so I hooked up on the concept of using these little sprinkler valves that people use for garden sprinklers, and they're not bad. Oh, how do I go to the next page? Come on. Well, look at this. Now, there we go. Okay. The other project that I had to deal with was, and all this comes together, is we have a water problem in Southern Oregon. Well, we had a water problem in Southern Oregon. It wasn't so much that the well wasn't that deep, but we were losing water level because they legalized growing marijuana and hemp. And so everybody decided they're going to be dope growers. And it was interesting because the price of weed dropped because gold rush, right? Everybody's doing it. So the actual cost of it's put a lot of people out of business. Anyhow, they were really bad at doing water management and they lowered our water table. So I finally said, this is getting to be a problem. Particularly, they also do bad. They're really bad at doing forestry management. So, rather than get out there and clean the forests, we would have these forest fires that were devastating. So, my solution was, look, we need to do our own water. If we have a forest fire nearby, we've done all the work around cleaning the land. Um, we need to be able to put it out ourselves. I know I'm going to lose power because utility, the first thing they do is shut the power. So we built a system here with battery backup. And there was a Raspberry Pi that you see that little screen on the side. There was an Apple iPhone app I wrote that would talk to a Raspberry Pi and get information like where the well was, how the charger was doing, what the battery percentages were. So it was kind of useful. I was getting to the point where if I had stayed there and continued to do it, I would have probably written some code to predict when to fill the well back up again in case we don't get enough water. The other project that we did back then was I built a chicken coop door. So the chickens live in a coop that we built. There's an electric fence around it, and in this case, there was a little Raspberry Pi that would schedule the door to open and close. There was a light that would come on in the morning to help them lay eggs, encourage them to lay eggs, and it put an electric fence that would come on at night to keep the bears from coming and eating up all because it happened a couple of times. So again, this was a Raspberry Pi app, and what's common among all those apps was that I built it as a web server that was running REST commands. So if I wanted to know what the status of the door was, I could send a REST HTTP query, and it would come back a get, and it would come back with some value. Or I could do a send and turn things on off. All right. Why am I? Come on. This is funny. It's giving me a hard time to connect. All right. So we got out of Oregon. Bought a bunch of property out here in Arkansas. We established a farm, and we're called stellaporta.us. Um, there's a picture there of containers. We we put everything in. I thought, let's save money rather than hire a moving company. Let's put these things in containers and put all our stuff in containers and ship it out here. And then the container guys didn't want to go over my bridge. And so they were like, oh, that bridge is, whatever. We're afraid to drive over it, even though it's built to county standards. So we had to actually unload the containers at a neighbor's house and get it apart and whatever. But so we're out here, and we've got this farm. I don't- So the first thing that we wanted to do was automate the irrigation for the farm. We had a lot of water. Well, first of all, there's like endless amounts of water out here. Um, but the previous owner had run plumbing out to the various pastures where the cows were, and to keep the cows, whatever, hydrated. And so I was able to patch into some of the irrigation, and we said, okay, let's do something here to automate this irrigation. We're going to do a little more than open sprinkler because um, we want to know with the way this garden is, we want to know like what the soil temperatures are, how much water we're getting, just some weather-based automation. And one of my other goals, and this was a big deal, was I wanted zero reliance on cloud services. And what triggered me on this was that I had a pump that I had used, made from an Italian company, DAB, DAB. They make an amazing pump, but their interface, as well as I've got one of these EcoFlow batteries over here, their interface is web-based and talks to their cloud server. And so if they go out of business or they shut down or denial of service, or just more realistically, if they go out of business, then I can't use the remote anymore. So it really bothers me, the whole cloud, like for agriculture, they've got you over a barrel. And then they turn around and say, oh, we want you to pay us so much every year. And I'm like, no, I bought the pump. I don't need to pay you for this stuff. So one of our goals was whatever we build, it, I'm not going to use cloud services, or I'm not going to depend on them. The mechanisms that schedule and all that stuff run on the Raspberry Pis locally. Um, I also need to be off grid. One of the problems I have here a lot is the remote utilities have a habit of, uh, I'm out there in the woods, right? I'm out there in the sticks. And so we lose power now and then, good storms, good lightning storms. I've blown out equipment left and right. Um, so another point was that when I say long distances, conserve battery power, I was looking at the open sprinkler, and one of the problems with that system is if you run a long run, like a 300-foot run to your sprinklers, the voltage drop is significant. So, I wanted to do something like that, but also if I have to transition a battery, I need to be smart about the battery usage. So why? Oh, I see. I have to click on the mouse each time. So one of the other goals, as I said, environmental ruggedness. Um, yeah, this thing needs to handle lightning strikes. It's in the woods, or it's in the woods. It's on a farm, and so everything is dirty and muddy all the time, And so, and I'll make reference to this down the road why I didn't use certain kind of connectors. Um, Software ruggedness, stability. One of the other issues I have is um, I want the software to be able to run 10 years from now, and if I don't make any changes. Right. And I got hit with this back in the Apple world. I would write an app for an iPhone and then they would change Swift. Right. They changed the language. And so you go to compile it again and you can't run on the latest operating system because they decided, oh, whatever, we need to use this great new feature that, dancing emojis. And so you need to update your OS and then update your builds. And so I'm like, no, I can't do that. And one of the things I liked about the Raspberry Pi is that, um, and I think it's more the Linux, is that they committed to a long-term stability. So you can get an OS that will still be supported for a while. The other goal here was that when I say expandable, just because I built an irrigation system doesn't mean I'm not going to use that for a chicken coop or for a front gate or for some other project that's coming down the road. So the same mechanisms that I'm building, I'm using for a variety of things around here. Uh, Self-hosted, well, I've already said that. Like I don't want this hosted on a cloud that requires like my network to work. And the other thing I'll just say is two more things. I moved away personally from iPhones to Android, and that's a whole other story in its own. But we've got mixed clients out here, so I just fell back to web-based user experience. And this is open source. I'm not selling a product. This is all, it's all out there. So I started with a Raspberry Pi and said, "Hey, let's just get this out the door and get it running." And so I went off and picked up some relay boards from oh God, WaveShare, nice relay board they make that the Pi fits on. Uh, so I started first with just taking the 24 volts AC, driving it out to the solenoids, and made it relay based. Um, and then I realized as I started to go on, I can't run this on battery. So let me do something better. And I can run those solenoids on DC. The way Open Sprinkler does it's interesting. They've and the guy behind Open Sprinkler, he's a great guy. He's really pretty bright. And so he went off and his name escapes me right now. Ray Chang or Ray something. So he went off and built a system that sends a pulse to the relays and then lowers the voltage. And so he has a little capacitor charge up, send enough to pull the relay to pull the solenoid in, and then drop it down a little bit if he for DC. That way he doesn't. I guess he thought he was going to overheat the solenoid, and that works well until you start running them long distance, or you decide to run like eight of them at once. And so some of our irrigation out here, um, like we'll run four patches at one time, and it kind of drops my water pressure, but it does work. So I wanted a system that would be a little different, and I'll get into the detail of this. So I went to using a pulse width modulated system, um, and I said, okay, I'll use I2C for I squared C for communicating with a couple of the sensors. Some of the sensors are a little bit further, so I use a differential I2C, and I'll get into that detail. And in some sensors, I have a couple sensors out there that are just one wire temperature sensors, stuff I buried in the ground to just look at the ground temperature. So yeah, I went off and decided, well, let's go build some boards and I guess I used KiCad, and that's a love-hate relationship, more on the hate side, um, but it's there, and it's no big deal to get boards spun up. And so what that picture is on the bottom, you see that like I did a little evolution. First there was the relay board, and then I tried to do the PWMs, and what you see is a Raspberry Pi flipped upside down, plugged into a board, and there was a daughter board under it that was doing my I squared C stuff. And then I built another, I had these little plugins that would do the PWM. And finally I said, all right, let me integrate all this stuff. So I put it on one motherboard, and there's a plugin board that does the PWM uh, to the various sprinklers. And again, I'll get into that detail in a bit. But what's interesting is that I built the board a couple of ways. I did it originally with all surface mount, and realized that it's really hard for me to solder like resistors. My even with a microscope, my eyes are not that great. So I ended up like going back to through hole. All right, let's see. Um, So yeah, we did some evolving hardware. The original hardware was this. Oh, this is worth talking about. So the original hardware, I'm using AC. I have a little AC to DC converter there. That little box in the middle. That thing didn't work out too well. And I'll get into that detail later. The new version right now on the right hand side, the one that's just about to get out the door, it's actually sitting next to me running right now. Has got a battery backup and a much better power supply and runs entirely on DC. So the first problem I had to tackle was the environmental sensors. And my first version of this, I went off and built some stuff with um, the queued up, the quick stuff that Spark Fun and a bunch of other folks. Uh, what's the name of it? The other company out there, I can't remember. But they they're using these little quick connectors. And if you see in that top picture, they're tiny little connectors. They're really easy to bend the pins on. And what's particularly bad is, we have a rainy, muddy day out here, and unless everything is completely sealed, those connectors clog up with dirt. Um, unless, and again, unless everything is completely sealed, every bug that can find its way into the thing, I mean, like insects will decide to try to nest in there and stuff. So uh, they're not very good for industrial. They're really great for lab stuff, but they're not a very strong industrial connector. And what I also don't like is that they're running on the 3 volts. They're more sensitive to noise. There are these guys that created this thing called NodeLink, and they've been around for quite a while. You'll have to look up the name of the company again. They're out here in like Iowa or maybe Oklahoma, but they're they live out in the middle of the country, and it's really funny to see this little company that has been producing I squared C boards for like 25 years. And so, but their boards are nice. They're using the 5 volt I squared C, um, and they use a much more common connector. Uh, and so, what I like about them is I don't bend the pins on those things. Now, I'm not saying like, if you played with the quick connectors, you know what I'm saying. It's really easy to like one figure out which direction that the connector goes in. It's almost like playing like USB. Sometimes you have to plug it in a couple of times. Um, but it could have been, again, I think it's great for a lab or for fun, but if you want to be industrial, we could do better. Um, the other thing that I do is differential I squared C. And so that's just a balanced line that you can bring I squared C out a lot further. And so in this particular case, I have next to the greenhouse, I have a walk-in cooler where we'll take the vegetables, bring them into the cooler, and I want to track the temperature and maintain that. So I have to go a little bit of a distance. So I'm using I squared C. Um, my first attempt at this, I said, I'm going to build a daughter card, what do you guys call a hat? And I put I squared C, I put the node link I squared C on it, the 5 volt version, um, the differential, and I did some one wire stuff and the Dallas one wire. And what was interesting is it's also isolated. So the I squared C that comes off of the Raspberry Pi goes through an isolation chip. It also has an isolated power supply. So if you short out the wires outside, or you get a good voltage spike, and that happens here a lot. In fact, I'll mention that. It's not so much that we get lightning strikes, but we get the static, the EMF in the air. So that has blown out a bunch of equipment over time. And so I started with building a custom card. One of the other things I did is I took the differential one. The SparkFun guys had a really cool device that converted from differential to I squared C, and I basically modified theirs, and until I finally built my own device. But just stood on the shoulders of giants, and there was nothing original here. For one wire, uh, oh, why does it say Hunter Rainbird? All right, whatever. That shouldn't be there. Hunter Rainbird uh, the solenoids. All right. Well, for the one wire interface, you can take one wire off of the Raspberry Pi, it does a fairly good job. If you want to isolate it, and if you want to run a couple of them out there at the same time, there's a really great chip out there, the DS2482, that will not only, it basically is an I squared C to one wire interface. And it runs as there's a kernel plugin that's a one wire file system. So one of the things it does that's really great is it turns out and isolates you can isolate it for, a fairly good amount. So when I'm getting lightning strikes, or I'm just getting some kind of electrostatic problems out there, these are sensors I buried in the ground. It doesn't get back to the Pi. Anyways, what's cool about the one wire file system is it basically shows up in the file system. So you just do like here I did a cat, you just open that file and read it, and there's the temperature. And so I'm able to, one of the things you'll see in that little picture is I record the temperatures daily, and the highs and the lows. And I don't know why that low is steady. Oh, yeah, that was the soil temperature. All right, come on. The sprinkler valves. Oh, that should have been the next page. So I'm using the regular Hunter Rainbird sprinkler valves. They're typically 24 volts. Um, and I'd mentioned before that Open Sprinkler was using DC and then having the capacitor charge, boost it to like 12 volts, and then drop it down to about, I don't know, 9 volts. And with the longer lines, that's not great. Um, it's also, I thought I could do better in terms of conserving power, especially if I want to run multiple valves. So what works better is to pulse width modulate um, the valve controls. And so it just so happens that TI makes this wonderful chip called a DRV 103. And they use this in automobiles everywhere. When they want to open and close solenoids, or I think they've used it for headlights. But the intent here is that this chip is great. You can say to it, turn on, run DC for a certain period of time, and then go into a pulse width modulation. Um, you know, what percentage duty cycle that you want. And so this works perfect for the valves. And the other thing that it does a little bit of isolation too, but the way it works with the valves is great. It'll pull DC, maybe like for me, I'll say, look, it takes about a second for a valve to go on. By the way, if you go to my Substack, there's an article about the valves, links to a video that talks about how exactly how these valves work, and they're ingenious. They're not just a little solenoid that opens and closes. It uses and depends on the water pressure to do a lot of the work. So the solenoid doesn't really have to work that hard. And one of the problems I had in Oregon is I was driving the water pressure from a water tank, and the tank wasn't high enough. So I didn't make enough pressure. I had to play a lot of games with getting the valves open. Here, my water pressure is ridiculously high. So, um, as a matter of fact, if you don't do the plumbing well, they come apart. But, but uh, what I like is that with PWM, you can still use a higher voltage. The voltage drop doesn't hurt so much, but as far as the valve's concerned, its effective voltage is lower. So, like in this particular case, it says here, oh, my average voltage was 7.84 volts, at 23 kilohertz, and I think I was running like a 40% duty cycle or something. All right. Um, okay, so this thing needs to work during power outages, and the top picture is kind of interesting. I used a very cheap Chinese AC to DC converter, take 24 volts in and give me 5 volts out or something like that. And every damn time the power would cycle, every time like we have a lightning strike or the power, more realistically, the power companies, they lose power and then they cycle their breakers. And so what happens is you have these long, long wires that run for miles, and they're basically giant inductors. So you'd get these amazing voltage spikes. I'd be out here with 110 volts, 120 volts, and I'd see 180 volts. Sometimes I'd see 200-volt spikes. And that little hole that you see right there, it just blew I've blown three of those things. And I finally said, okay, we're done. We're not doing AC anymore. So I tried a couple things. A lot of the surge suppressors out there are not very good. They're designed mostly to prevent your EMI from getting out to the grid. Um, Very few of them are actually great surge suppressors. So I actually got to the point where I said, okay, I'm going to build my own surge suppressor. And it turns to be a way more complicated thing than I thought. I actually got a copy. I don't know if you guys have ever seen The Art of Electronics. That it's a great book. I had to go back and look at it again and read all about how this was done. And there's guys who did this back in the 40s because they were dealing with equipment back then that were sensitive. But one of the things I also found was that if I got a good power supply, so I got one here from Meanwell, and this is amazing. The DRCs are amazing because they're integrated, they're UPS kinds of supply with an integrated charger. So I have one, what you're looking at right there is there's a 12-volt one, it charges the battery. Um, you pull the power and it just automatically transfers to the battery. And but one of the other issues you have to deal with is if you want to shut off let's say the battery's starting to run low, you don't want to damage the battery. You want to shut off the Pi and do it, gracefully. So I've had to build a custom circuit that identifies when the battery's going low. The power supply gives you an indicator. It says, hey, AC is being connected, AC is active or AC is gone, and there's another one that indicates that the battery's starting to get below levels. And so what I have is it will gracefully tell the Raspberry Pi, hey, it's time to shut down your Apple run, save whatever files or stuff that's open so you don't damage the SD card. And then I actually shut it off. There's a relay that goes on. And the relay is an interesting discussion because what I did, and I have a whole, oh, I guess I haven't published it yet, but I used this back when I was building my car radio. I used a latching relay that was used by Mercedes for their fuel injection systems. And basically, what's nice about it is you don't have to power it. You click the set button. You click the set with 12 volts for like half a second, and the relay clicks one way, and then you hit the reset for half a second, and it clicks the other way. And so you don't have to keep the thing powered to use up battery time. So I got a nice little circuit that decides, oh, okay, the Raspberry Pi wants me to shut off and it clicks itself off. When the power comes back on again, the AC comes back on, it powers itself back up again. There's a lot of hats out there that try to do battery backup, but they only power the Pi. And I've got a lot of 12 volts things that are out there, accessories that are running, motors and stuff. And so in the case of my garden, you know, what I need to do is when the power goes down, eh, I still have to irrigate during that day. So what I'll do is this thing is designed to run and do complete irrigation cycles for 1 or 2 days. Um, and even if I don't have power, and that buys me time if I need to hook up a generator or do something else. We're transitioning to completely solar, but we're getting there. It's going to take a while. All right, come on. All right, so here's an interesting story. So there's software. Can I go back? Yeah. So there's software, and I call this project the Pi Internet of Things. Um, the number one thing was the software stability, right? I don't want to break every time the OS gets updated. So I had to choose, look, let me use a language that's not going to change every day. Let me make calls that aren't going to get changed. And so I'm taking advantage. Like I said, Linux has this wonderful, like, if you look at the Pi OS, um, they guarantee extended long-term support. The other thing about my rules here was that it's self-hosted. So what I ended up doing is writing it in C, and I chose CLang and well, it's C, C++, but it's C++, but it's kind of a comp. I'm more of a C guy, so it's kind of both. But I chose CLang because it compiles faster. And, you know, uh, I do use a Pi 5 these days to do the compilation, but every now and then I got to make a change and it might be running on a Pi 0. So the CLang runs pretty well for that. Um, And so if I just make calls to standard Linux libraries, then I don't have to worry. Like for example, I didn't use wiring pi. Wiring pi was a good example for me. I learned, gosh, the guy killed his support. Somebody finally picked it back up again. For a while you couldn't find the library. And so I just said, look, I'll just call. as low level as I can. So for I squared C, I just call the standard Linux I squared C libraries. They work really well. Um, and the server is pretty cool. Basically, the server is just a TCP/IP server. It runs a REST API. It runs HTTP. It runs up, like an HTTP port, and it takes REST commands, parses them, replies REST. I do all the right things, and there's a little bit of security built in, and that's a whole conversation on its own. Maybe if you're going to ask me about it, we'll jibber jabber about that. Everything's an open source. Everything is up in GitHub. Okay, so how does this thing work? It's pretty neat. I'm trying to be flexible here about stuff. Um, I have a config file. Uh, it's JSON. Maybe it could have been something else, but that works well for me. Um, and so let's say you have a device and you want to add a device, like I've got a temperature sensor I want to add. I tried first to play this game of going out to I squared C and figuring out what devices were out there. But not everything is I squared C. And some things are GPIO, some things are one wire, some things are custom. So fine, we'll define them in a table. So in the JSON, there's a device entry. And so in this particular case, it identifies and says, hey, this thing is a TMP 10X kind of temperature sensor. Here's the address it's at. And the data type says, oh, it's a temperature. So I've given data types like I've things like voltages, temperatures. What's useful about data types is if I say temperatures and I say, oh, give me the human readable, um, it'll convert it to something I can look at. Same thing with voltages. It's just it'll give you the raw data too, but sometimes you want to do some interesting conversions. Um, and the other thing that I talk about is there's a key. So what happens is there's a key value database out there, and in this particular case, if I look for key temp 48, I'll get back what the current temperature is. Um, to get things going, I wrote a whole bunch of plugin libraries originally. I said, okay, gosh, what I like using the SHC 25s and the 30s, the TMP 10 whatever's. Um, there's a humidity, the BME one. And so I wrote a bunch of plugins already. And as I started to do this, I realized, oh, this is going to be hard for somebody else who wants to do this. Why don't we make them? Because they have to recompile every time. And I said, well, let's just make these shared object libraries. I've done this before. Back when I was working on the encryption world, I used to be able to plug in my encryption algorithms. And so right now they're just Linux shared, and I've got examples of how to do this. But what's nice is I'll have a folder with a bunch of plugins. So if I come up with a new device, just write the driver and stick it in there. So it's not a Linux driver. It's just there's a simple API that I've defined, and it's actually a C++ API, but like, and it has stuff like, oh, here's the key. I'm set, initialize. Um, tell me what keys you know about. Um, what's the value of this key? Whatever. And so, it's REST, right? And so here's a good example. If you look at the lower left side there, it says, oh, get slash values, right? So go get me a value. I'm interested in temp 48. And it bounces back and says, oh, here you go. On the right hand side, it goes, it's 76.10 degrees Fahrenheit. Because that's what I use out here, right? But you can see it's 24 in Celsius. There is the actual value. You don't care about the display thing. I mean, you can just change that. What's also interesting is it tells you the last time it got that value. So this makes it nice for a web interface. You take the rest, or for some other user interface, you take the rest, and you can look at the time and say, oh, how old is this value? I mean, is the sensor still working? And I don't have to query them all the time. What happens is there's one thread that's querying sensors and another thread that's completely independent that's doing all the web stuff, or the REST interface. Controlling them is pretty much the same thing. You do a put. So I've got this greenhouse light. I want to turn it on. I've defined this as I defined one of the GPIO lines, to be a greenhouse light, set it to true, and it comes back with, yeah, sure, I did it. Success. Um, what else is cool is I built a interface to SQLite, and I said, okay, you can mark certain sensors as being, I want you to track these things. And so first I was starting to track like the temperature sensors, but I don't need to know during the day how much it it fluctuates. Like I don't have to watch the fluctuation up and down. That's just not necessary for us. What I would like to know is what the max and minimum is. And so I can mark either like make an update in the database when there's a significant change. There's a way to identify a device and say, okay, this particular key, if this thing does a significant change. And again, like I said, with temperatures and or with voltages, that they mean different things. Like is zero point 0.1 volt or is it a 10 volts or with a temperature, like do I care if it's half a degree? I don't. But if I see a trend, so it'll track that. But I can also say, hey, give me the minimum and maximum during the day. So what the server's doing is as it's querying the devices, um, it calculates for a given day what the high and the low is. And that actually turns out to be much more complicated than I thought it would be. Uh, if you actually think about that algorithm, it you have to do this on a 24, it's not a 24-hour basis. It's I need to know what the day is. So you might not have the maximum minimum for the day because it's like only 3 in the morning. So like you'll see like this major dip right there. Well, that was because the server had shut down that particular day, and or it only ran for a few hours, and it was cold at that particular time of the day, so it never got a good high on that. And I'm since then I've done some interesting filtering to figure out what stuff is, but it was useful to track and say, oh, okay, well over those 3 months, this is what I saw for temperatures, and so you can. Again, this is all configurable, but what's nice is that you can access the data. So what's happening here in this little picture is I'll put up the air temperature. I'll say at the bottom, oh, okay, here was the high and the low during for the day. And if you click on it, it'll pop up a graph. Okay, the next thing that's really important for us is I have to have this concept of scheduling actions because what's the point of just I don't want to turn the valves on and off by hand every day. So, you know, um, one of the things I discovered with when I was doing the chicken coop is I don't necessarily want to do things based on the time of day. The time of day might be relative to things like sunrise or sunset, and particularly with the chickens, it was sunset because what I wanted to do was open the door in the morning, kick them out, get them out in the garden doing their thing, and then they knew enough to go back into the coop at sunset. So otherwise, I have to change the time for sunset every day. So there's a little bit of code in there that does some calculation and it says, oh, okay, there's sunrise at a certain hour, sunset at a certain hour. The way this works is kind of fun. You have to give it, your lat long, and it does the math, figures out when it thinks that should happen. And it also turns out if you haven't played this before. There's a lot of different kinds of sunsets and sunrises. There's, your actual one. There's civil. It's like when call first light. There's a nautical sunset. I mean, it's pretty fascinating. And I also keep track of the phase of the moon. Um, I guess to farmers, that's kind of a thing, but it's been useful for us to know, like, for example, how many hours of daylight we got, or how long a day is. So we can do some things like, for example, there's some things I want to open up and water in the morning, but not necessarily in the afternoon when it's too hot. So I can we can I can describe events and say, here's an event. Um, when this event happens, do these things. So, for example, let's take like a valve. No, we'll take the chicken coop door. I could say, all right, there's this device called, chicken coop door. It's binary. It understands up and down. And I can say, well, open based on this particular event, sunrise. And then I can do another event. I can do another schedule action, say close at this other event. Um, when you define the events, you can define them as either time-based, like I said, sunrise, sunset. You can actually say, you know, 6 in the morning. Also, I mean, you can do it based off of midnight. Um, there's chrono. I also have cron support. So there's some things I might want to run every hour or whatever, or once every 24 hours, or once a week, which is kind of interesting here. We have a couple of products that we will do on Thursdays, or every 5 days or something like that. Um, I have events that can happen at startup or shutdown. And so the other thing that's fascinating is the events can trigger on conditions. So like I can say, okay, if the cooler temperature gets above 45 degrees, the walk-in cooler, I need to know something. We need to do something about that. Send me an alert, do whatever. If the rain sensor indicates 1 or 0, it's raining. So with the rain sensor 0 says, hey, don't, only run the sprinklers when it's not raining, when it's not wet. If it's wet, shut them off. And I started to say, gosh, this looks like an expression evaluator. How do I do this? And I was going to write an expression evaluator, and I realized that expert TK expression TK is a great one. So there's a great library out there. This thing takes really complex uh, expressions, evaluates them, compiles them, and you can run them later. So I can run them. I can run them against my little values that I've defined out there, my keys. So like I said, rain sensor was a particular key that I hooked up to a thing, or cooler temperature was something I hooked up to a temperature sensor. Um, User interface right now, I'm not taking a lot of time doing it. I basically took another Pi, ran a web server on it. In fact, it's a Pi 5. It's running Docker, so I've got some other cool things going on it. Um, Really boring HTML, CSS, JavaScript crap. And so what happens is you go to the site, um, it makes REST calls to the server, which is the Raspberry Pi that's out in the yard, and it gets back the data and gives you a little display. And I know people can do much more interesting things with it than I can do, but I'm like, I just need this to work right now. Um, Security is kind of an issue. So one of the things I've done is, oh, and my internet here is Starlink, so I can't get a static interface. So one of the things I do is I use Cloudflare, and I use the zero trust tunnel to get remote access. So I can define a website out there, a DNS entry out there, and it will tunnel through to the Cloudflare, which is running on on the same computer that runs a web server, but it's running on another Docker image. Um, and that talks to the web server, and the web server talks to the device. I've got some interesting security built in. We can always talk about that. This is a work in progress. I Back in March, 2024, we installed the irrigation. Actually, this is what's really interesting. We moved here. I want to tell you, in the January of 2024, within a couple of months, we built the farm. Like, we really kicked butt. We went out there and worked hard, built the farm, dropped irrigation in. I got it running with open sprinkler. Before the end of the year, I said, let's just, I'm going to create this Pi server thing. This and by March, we were running it full time, and a lot of messing around with things to get it to work. And like I said, there's more Pi projects in the work. So let's see. Here. All right. So it was fun. I've been building stuff all the time. Um, Go ahead.
Thanks very much.
What can I?
You can hear me okay? Yeah.
Yeah.
I did have a few questions. So
Yeah,
you mentioned
please.
long distance, with respect to the power. Like what sort of voltage drops are you getting over what sort of distance?
Yeah. So I'm using um, 24 gauge sprinkler wire, the usual, the usual, sprinkler wire. Um, what was I seeing here? I it was significant enough. I don't remember if it was like 3 volts or something. It was enough. They're not the best connections in the world. They're outdoors. They're dirty. They're wet. Um, hang on. Let me get. Um, so I was seeing enough that the there it goes. Hold on. I was seeing enough that it was causing problems with what do you call it, with open sprinkler.
Right. And what about the I squared C differential? What sort of distances were, I guess that worked
Oh,
fine. I
I'm only
squared
going about
C,
30. I'm only going about 30 feet with it. But you could go 100 feet. I mean, like anything that's differential can go pretty far. Your real issues are going to be
yeah,
timing, and I'm just reading temperature sensors. So it's not like I need to run it at 400 megahertz. I can run it a little slower, 400 kilohertz. I can run it at 100 and it's fine. Um, what I cared about was that there's some motors out there, there's some fans and stuff and cooler, there's the cooler is actually interesting. It's basically we built a structure, put a bunch of insulation around it, took a mini split, and then hooked up a cool bot, which is a device that makes the mini split run at a much lower temperature. It fools it into thinking that it's warmer. And so that when the mini split runs, there's all kinds of like electromagnetic noise. Um, even with the filters I put on there. So this kind of helps a bunch when it runs by all those wires. But the thing is, I'm not doing so. I'm running basically like 10 base, like Cat 5. I hook it up over Cat 5, so it's basically a Cat 5 cable going the differential, and the other side of it, is just it converts to I squared C. Um, you- oh, it's running at 5 volts. I suppose I could kick it up to 12, but I'm not. I am not seeing any noise at all.
right.
Nothing significant.
So is your hardware static now? You call your hardware design, you don't feel need to change it?
No, it's going through one more change. There's I talked about the relay thing, and one of the mistakes I made was okay. So the way this works is you've got this little it's not very big. You see that you're looking down on one of my test projects here. There's a little brown, little gray square right there. That
Yeah,
that relay right there is it's a fuel injection control device. You know, it's about 20 American dollars. But I think Hella made them originally, and so they're Mercedes, BMW parts, um, and they're 12 volts. Give them a pulse. And so what I did is I said, okay, look, um, the Raspberry, the powers, the signal that comes out of the power supply indicates that AC is on. So what I need to do is I don't want the relay to be on the whole time. What I want to do is I want to pulse it for a short period, just enough to get the handle to slip over, the contact to slip over. So I said, okay, this is simple. This sounds like a 555 project, right? Let it run for half a second whenever it sees a pulse. Maybe put a Schmidt trigger in front of it or something like that. I don't know, but I what I discovered was, and I'm like trying to be smart. I'm like, oh, let me take some board space. Let me use a 556, which is the dual 555s. And what I discovered was that they're really sensitive. If one 555 goes off and pulls a load, and it goes through a little it went through a little JFET or something like that, it would set the other 555 off. So what I was doing is I was getting the turn on, turn off right away. I also added a couple buttons in there too. So, for example, I wanted a manually, let's say the Pi said it wanted to shut down. So, I do a sudo shutdown, and when the Pi shuts down, you can configure the Pi to take one of the GPIO lines and change its state when it does a shutdown. So this tells my shutdown circuit pull the relay in the other direction. Um, So I put a little button there, and one of them is, restart again, basically come back up manually, because even though the Pi told you to shut down. And I was just having these situations where it would come on, go off again, and it's like, or go off and go on again. And it was the 555. So I said, okay, let's redesign this again. And so the current stage, I'm using 74 something or other CMOS. I can't remember the part, and it's working 123s or something. God,
Yeah.
I've been doing this for so long, they just jumble in my head. But so the current circuit's going to be a little better, a little more rugged Smith triggers, and but the fun part is, trying to fit all that stuff, and KiCad is not. I know some people love it, KiCad, whatever. It, it could be better, right? I mean, it's there. I wish I could do better with the board design, the board stuff. There was a company locally, like I'm trying to buy locally if I can. There was a company up in Oregon that was building boards. They were great, but then they wouldn't take a board the size I want to do. And so I ended up doing one of the Chinese board companies. They're fine. They turn around. They get through customs quick enough, and so bam, I got a board, and the quality's been good. So the last thing that's going on right now is the last rev of that. I spent a lot of time working on how do I suppress EMI suppression, or EMF suppression, just so that I don't get a lot of the spikes out there don't affect the Raspberry Pi. The Pi is incredibly sensitive to stuff, especially the GPIO lines. You need to be careful of that.
Yeah. And what sort of uptime have you had? Like, has this thing been running for like a year straight without problems
Yeah,
or?
yeah, yeah. The one
Oh,
that's out there, when it doesn't blow up, so software is pretty bulletproof. Um, I mean, I've been building stuff forever, right? So I get it. The And it's not like it has to do complicated stuff. Basically, what's it doing? It's querying an I squared C, looks at the values, does a little bit of finagling, decides, oh, this needs to go in the database, sticks it in a SQLite database. Um, there's just a standard TCP/IP basic server loop. Command comes in, do it. And so that's not really a big deal. Um, But if you cut the power to the Pi, you can corrupt the SD cards. Now, I mean, the answer to that is, oh, well, I could use, one of the better Pis and use, NVRAMs and all this. I like using the Pi zeros, the Pi 2 zeros. They're cheap. Um, they've got Wi-Fi. Um, they're easy to work with, and they've been incredibly reliable. I've only blown out one of them. And I think again, it was I squared C. I didn't realize what until I understood what was going on, and I started building some better stuff. Um, One of the optimizations I made just recently was I this talks Wi-Fi to my network, right? But now it doesn't need the network to run. Once you set it up and it's running, it's scheduling, it's just going to run. Okay, and still talking to sensors and stuff. It's just if you don't have a network, you can't really get to it. One of the things I realized was that, well, okay, what if I want to change my Wi-Fi, or let's say I want to bring it down to the local college and talk to in the makerspace there and show them a demo. How do you get to it? So what I did is I added a nice little simple. I don't know if you can see this right here. See if you guys get if you let me get the camera. So what is the camera pointing at? That's not pointing at anything. There. Hold on. There it is. Okay, this little device right here is a uh, USB to serial, right? And so I just hooked up a device that hooked up to the built-in serial, the TX0, the serial port, and I can plug a USB cable into it. Opened up the console. I don't mind it because look, I'm not worried about somebody hacking me physically. Like if they come onto the space, good luck to them. But if they come onto the space and they're actually plugging into my device, I'm not too worried about security there. Like you have to go a long way. But I mean, you got to realize I got a half a mile down my driveway here before you can get to the. Sophie's been here; she understands. Um, but you know, web wise, there's much more security. Anyways, building in a console as a backup is a great thing. One of the things I was trying to get to figure out was why I was losing connectivity. And so I was having the classic Raspberry Pi Wi-Fi issue where it would power down the Wi-Fi and just because it thinks that no one's doing anything with it. And I'm like, I had to figure out what was going on with that. Like, why was it losing Wi-Fi? Or maybe the Pi comes up before the network does. And so sometimes that's a little bit of a problem with the Wi-Fi's. Or, what's happening here is that the greenhouse is not on a generator. It doesn't have to be really, and um, but the Pi might be running on a battery at that time when the power fails, and so I still wanted to run the sprinklers. So I don't have necessarily a console. I didn't want to put a user interface on the screen. It's just not necessary.
Yeah.
I suppose you could put an LCD on there and go in and play with it. But so if you're going to build something embedded, give yourself access to a serial port. Um,
Okay,
one of the other things that, yeah, go ahead.
some questions in the chat.
Yeah, yeah. I
Marco,
didn't
if
see
you
them.
want,
So
yeah.
let me see if
So Marco,
I can see the chats. Okay.
yeah. So Marco asks, have you ever evaluated the adoption of a Home Assistant to use on the Pi?
Yeah. Uh, all right. So one of the problems that Home Assistant in particular, this is a good discussion. I use Home Assistant in some places. It is updating every other week. Well, whatever they update a lot. Um, I might not be. So this farm is let's say this. Let me say this in a not a creepy way. This is what I'm going to call a generational farm. All right. It's going to stay in our family for generations. So this stuff needs to work 10 years from now. So part of my thoughts are is that if I was to use that and Home Assistant makes some radical update change, which they've done, I've had plugins break. Um, this still needs to work. So that's part of my software reliability or hardenedness is that you might argue say, well, you could do much more cool things with Home Assistant. Sure. One of the easiest things to do here is to build a bridge between the REST interface and Matter or um, what's the other protocol you guys use? Uh, there's the other protocol that Home Assistant likes to talk. Whatever they are, and you could just build a bridge, right, to transmit to do that, and you could even run on the same machine, or you could run. I actually think, yes, not Zigbee. I don't mean that. There's the software protocol. There's a common software protocol that everyone uses. Matter was one of them, and the other, I think, I can't remember. Anyhow, but it's nothing to build a plugin like that, And again, what I would do, yeah, yeah. Oh, okay, hang on. What I would also do is probably run it on another server. So again, the idea behind this little Pi Zero is it's running minimal amounts of code. It doesn't have to run fast. In fact, I can dial down the speed if I need to. I'm just trying to minimize the amount of power the thing's running. And so, have I considered running Grafna? Yeah, I did. And then I was like, oh crap, this is. I didn't want to go through all the licensing stuff. Sure, if you want to do it, then write your own. I know it's not a hard licensing thing, but I'm like, you know, it's overkill. And sure. Um, Solar panel attachments to your batteries. Sure. Um, I use it's not a big deal at all for solar panels. As a matter of fact, the if you go to my Substack, there's an article there about how I did the cameras and solar. And so one of the things I have is I'll have a solar panel. So I have cameras around the property, and it was mostly for me to track what animals were running around. I wanted to see like if there were coyotes or whatever, who was coming into. and it's occasionally useful if there's a lost dog. And so I have a camera way down the end by my driveway. It's out of range of power. And what I do is I Wi-Fi. I have a mesh, and I Wi-Fi down to it. Well, the thing about a camera is that if it's a trail cam, it only has to run for a little bit. But I'm doing it 24/7, looking for things. It's running off of the uh, Unify base, um, and um, with the solar panel, it charges a battery, but this has to run 24/7. And what happens here is we get an amazing amount of sunlight. This is Arkansas. I mean, we have, but in the wintertime, I could go 4 days with rain and not a ton of sunlight. So solar's okay. I've got to do both. I've got to be able to do off of a utility. The house that I'm building right now is going to have solar generator, a propane generator and utility until I get off the utility. But it's a good goal. And yeah, we can run on solar. Okay. What other questions am I getting here? Let me try to evaluate. Oh, connectors. What did you choose in the end? Um, MQTT, by the way, that's what I was thinking of, a mosquito. Yeah. The so the connectors um, are the little Molex that NodeLink. Give me a second here. I'm going to tell you the name of the company. Um, OYNC. They're who are they? Oh, Node. Um, NCD, National Control Devices. So National Control Devices did a cool. I have a whole article in this there, too. That like if you zoom down there and read about I squared C, I got into detail about who they were. Um, I like those little Molex connectors. They're strong. They're pretty rugged. They're not. Do I have one sitting here? Um, they don't like break in my fingers. you know, I mean, not that I'm like, a brute, but like they're just, uh, they're not um, as fragile. So if I grab one of the connectors here and I bring it over, you know, they're they look like that, right? And when you get to them, they're big enough. Where come on, get screen. They're big enough here that you can hook them up. What's strange about this, and it took me a little while to figure this out, they have an in and an out, the national control devices, and you need to pay attention to that because here's the ground wire, and there's the ground wire on the opposite side, right? So you can plug the connector in wrong. It's not that a big deal. It doesn't damage anything. It just doesn't work. So I think what they did with no, with Quick is they wire them both the same way. So or they made their cables so they cross over. Um, I have to go back and look at them, but I just stopped using because they just kept getting dirty all the time and just around the house. And I'd keep bending pins. They were just so tiny that you just bend the pins all the time. Oh, what'd you say? To resolve this, you store the values. Hmm. Yeah. To resolve this, you store the values. What do you, ask me what you're saying. I'm confused. Can't you store the values on the Raspberry Pi and read them every time?
You know,
What's that question there? The last one, the resolve to resolve what?
I guess just a way of doing it.
Oh, so but I understand what the question is. So what I do is I maintain an in-memory state of all the values. And when the values change significantly, I do a write to this SQLite database. Um, I can partition things if I need to, where only part of the the RAM. Like I don't really want to touch the. I try my best to not touch the SD card as much as I can. Like you could make part of it read only if you had to. Um, you could split it and do all kinds of stuff. It's not worth the trouble. I haven't had that kind of crash. And I know people say, well, you're going to wear down the SD card. Yeah, but I mean, sure. And I think one of the failures of the Raspberry Pi is that they use those stupid SD cards, right? I'd like to see. I mean, there are alternatives to it. You could put the database on I squared C and some little device out there like that, or plug it in as a USB device, and then have another card just be the database. But SQLite's incredibly good.
It is
Uh,
good. Cool. Any other questions?
so let's see. I've got some interesting questions for you guys that you can help me with regarding this.
Yeah.
Um, how have people solved this problem? Like, I don't know if I'm overly sensitive to the SD card being burned out, but like, how do people solve this problem of embedded devices with their SD card? Do they just make them read only?
Anyone has thoughts on that?
Hi, right. I use M2 cards. I'm doing a lot of writes. The Raspberry Pi 5 supports it. Raspberry Pi 4, you can USB boot and you can put an M.2 card on the back of that.
Right.
So if I know
Yeah.
I'm into a high write situation, that's what I would use. Otherwise, I'd try and minimize writes and use the normal memory card.
Yeah, and I think that's what's happening here. I've looked at the Pi 4s. I mean, well, Raspberry Pi 2 is, it's not a bad device. I looked at the Pi 4s and the Pi 5. We've got a bunch of them running here and there. I have them all over the place. Um, the the problem is they're significantly power. They eat bunch more power, and I'm really trying to run off of a small battery. As it works right now, I can go a couple of days with this tiny battery. It's great. And I've got a little bit bigger one here that will go about 5 days without power. Um, I can tell, like, if I don't have events scheduled, I can lower my power. I can lower my speeds. Do stuff like that. Um, yes, turns this. I did that early too, by the way. Turn and swap on the SD cards. Yeah, absolutely. That's the first thing that went away. Thank you for reminding me about that. Um, again, it'd be nice if they had they had worked out a better device, or if somebody made an SD card that had a different architecture. You know, I'm just curious if anybody has solved that problem. Um,
Yeah, I do think
no, and that's
the newest Raspberry Pi OS is quite prone to corrupting itself. You just lose power and it can't restart. Or they never had
uh,
that with earlier versions of the Pi OS
in the light version or in the user interface version.
user interface version. Actually,
I
both.
haven't. Okay,
Actually, I've never used the light version, but in my
like
embedded
light's been
system,
pretty reliable with me. Light,
yeah,
I've been beating the crap out of light, and it's been working wonderful. Um, I mean, it's just I mean, it's nothing special. And I think the only other thing I had is yeah, I was just wondering like how people have done. You've had a lot of great folks there doing embedded system stuff. I'm just wondering if there's any other hints or tips they might tell me. Well, let me ask you a question. Do you like, is there objections to building your own server like this? I mean, again, I know people say, hey, why don't you use home automation or whatever for the interface? Would you use home automation? I mean, part of my problem here is that, if I'm using the home automation stuff, I might not have a network, right? And so that I want these things to run without a network. Yeah.
yeah. I think it's. I mean, personally, I think it's a relatively simple problem, so it's probably overkill for what getting to
Yeah.
home assistance like that. But
Right. Right. Okay.
sounds like you have a good architecture that you're happy with, and you can do whatever you want then, can't you? So,
Yeah, no, I mean that's the great thing about it. It's not very complicated. Um, um, the device plugin thing was a simple, something comes along. So I have this other quick concept. I'll tell you, say I had this concept of pseudo devices where it looks like a device, but it talks to other devices. So like in the case of the sprinkler device, it it talks to another device that's a GPIO chip somewhere. And so I define it and I go, okay, here's this thing called a sprinkler. Sprinkler one talks to GPIO of that device over there. Um, and what makes sprinklers different is that you can do things like, um, oh, turn on a master. If I turn on any of the sprinklers, it turns on a master valve first that opens up, supply to things or, yeah, or whatever. So those are kind of cool. I use DTMF for mobile. I use DTMF codes for mobile. Oh, hey, that's a great question. Let me ask you this, everybody this. If I want to send a text message to myself from the Raspberry Pi, what's the given way to do that? I mean, notifications. I mean, I
Yes.
suspect you just send mail, but email, but
So first of all, you can use a number of third-party providers that do an API. It's just again a
Mhm.
REST API that you can submit requests to send text messages. You generally buy a bunch of credits to say I buy 1,000 credits and I can call them
Right.
offline as I need them. Or you can actually just get IoT SIMs that have no real cost per day, but they charge you for the usage. Another option would be you can use an app called Pushover.
Hmm.
So that will you install the Pushover app and then you can register with them and send notifications to all the subscribed apps.
Yeah, that's what I was wondering about because like I used to do this with the Apple system all the time, their notification stuff. But that was only in their ecosystem.
And
And so I need to be able to notify, yeah, push
Pushover is
app, push
Pushover.
over.
Yeah.
All right, I'll look it up. Thank you.
If you have
Thank you. I
access,
appreciate it.
yeah, access to Wi-Fi, you can also just do it via Telegram. Telegram has an API that lets you
Right. Ah,
jump on.
there's pushover. Okay.
Can I just say one thing? So I think it's amazing, Vinny, that you're doing it yourself. And I think more people should be like that because like nowadays people don't realize once you actually learn rest and things like that, just how easy it is and what those people that don't learn it are doing is they're allowing the big organizations to then start to take over, and that will lead to a point where actually we're all become dependent on them. So 100% the fact that you're building it yourself, you're doing it yourself, like I always advocate that because I think people just get lazy and then they go to a third party, and before you know it, it becomes even more complicated. Let's take back that ownership and let's do it all ourselves properly rather than allowing these big organizations to make money off of stuff that's just super simple to do once you take the effort to learn.
So that's a really good point. This is I got to say something about this. Thank you, Sophie, because it's make reference to an article I wrote about exactly that, the independent stuff. So one of the things about being out, in farmland here is that we're incredibly independent, and I can't. It's not that I don't want to depend on other things, but it's like denial of service. If you have a denial of service, why should my stuff go down? But it's the same thing about knowledge. So in this process of having to go and learn to make hardware, well, I've done that before, but I've had to go and learn 3D printing. In fact, I need to leave in a little while. I'm taking a CNC class, so I need to be fabricating stuff in a CNC shop. I wrote a. Please go visit my Substack. I wrote this great article about why go out there and learn new things, right? And one of the problems that we have as humans is we become so specialized, we're afraid to fail and learn new skills. And so I think given that we're now like outsourcing our knowledge to AI, uh, and I use AI a lot to try to do some of the board design. It's incredibly wrong most of the time, right? I mean, people tell me what they use it for coding and stuff. I don't know. I find that it makes a lot of mistakes, um, because it's basing itself off of knowledge that it's found on the web, and a lot of that stuff is faulty. Um, I think what you're saying is very, very true. So yes, learn new skills. Um, and this is a big, deep philosophical discussion. But anyhow, yeah, go check out my Substack. There's plenty of material there. It'll be fun. Thank you. Oh, I lost your audio, Richard. Oh, you are muted. There you go.
Great, sorry, thanks. Yeah, thanks a lot for that, Vinny. That was a really good presentation. Lots of good
Thanks,
questions there,
guys.
good ideas. I really like the idea that you're just rolling your own, really. It's really good.
I mean, it's a lot of fun. The biggest thing you've got to be willing to do is fail,
Yeah.
right? And just bounce back off it. Like I've got a whole collection of boards that are failures, right? So fine,
Yeah.
we got it correct. Yeah.
Well, I think if you're buying an ecosystem, you're just failing, but you're failing different things, and it makes it a bit easier sometimes, but a lot of times just have with different problems.
Yeah.
Cool.
Yeah. Okay.
Great. Thanks very much, everyone.
Thanks, guys.
Sign off from here.